Hello, I am Peilang. I'll be discussing our work on temporal restoration and spatial rewiring for source-free multivariate time series domain adaptation. This research is a collaboration between NUAA and I2R, ASTA, and will be presented at KDD 2025. Real-world time series models often suffer performance degradation due to domain shifts between training and test distributions. While traditional unsupervised domain adaptation methods leverage unlabeled target data to address this, they typically require source data during adaptation, posing privacy and security risks. Source-free domain adaptation overcomes these limitations by operating without source data and has shown promise in capturing temporal dynamics. However, existing SFDA approaches inadequately model spatial dependencies in multivariate time series, hindering their adaptability to complex real-world scenarios. Spatial correlations between sensor channels offer domain-invariant cues that improve robustness to distribution shifts. For instance, in human activity recognition, temporal patterns, e.g., stride length variability, may differ across individuals, but spatial relationships, such as joint angle consistency between limbs, remain stable. Besides, these correlations enable richer context modeling by capturing inter-channel dependencies, and preserving them during adaptation significantly enhances cross-domain generalization. This leads us to our central research question: how can we effectively model and adapt both spatial temporal dependencies and multivariate time series simultaneously without access to source data? This is a challenging problem because we need to capture and preserve both dimensions of information during adaptation while respecting privacy constraints. Previous approaches have focused primarily on temporal aspects while neglecting the critical spatial relationships inherent in multivariate time series data. To address this challenge, we propose TERS, temporal restoration and spatial rewiring. Our approach employs both temporal restoration and spatial rewiring tasks to ensure spatial temporal consistency of sequences across domains. To our knowledge, this is the first method tailored for multivariate time series source-free domain adaptation that explicitly considers channel-wise spatial relationships. Additionally, our approach can be seamlessly integrated as versatile plug-and-play modules into established SFDA methods. We evaluated our method on 3 real-world datasets. These datasets vary in their characteristics, with different numbers of channels, classes, and sample lengths. For fair comparison, all methods employ the same spatial temporal feature encoder as the backbone network. The tables present the F1 scores across 5 cross-domain scenarios for each dataset, demonstrating the effectiveness of our spatial temporal adaptation approach. Results on the sleep stage classification dataset further verify efficacy of our method. Ablation study and versatility analysis underscoring the contribution of our core design. Parameter analysis reveals robust performance across varying weights, with stable trends across datasets. Heat maps highlight the importance of balanced masking ratios. Moderate ratios optimize learning, while extreme values degrade information recovery or challenge adequacy. Visualizations demonstrate marked improvement in source target feature alignment using our method, confirming its efficacy in bridging domain gaps while retaining discriminative structures.